Okay. Hello? Hello? Can you hear? Okay. Sure, the mic is on. Okay, the mic is on. Okay, let's go. Wah, wah, wah. Looks so big, kan? The step, actually the step very easy one. Sure, very easy one. Okay, we start with energy investment phase. We start with step 1 until step 5. Okay, what happened in step 1? This one have to hafal lah, but it's not really have to hafal. Actually, it's very... The name is not that complex, so I think you can understand one. What happened in step 1 is called phosphorylation, meaning adding of PI, which is phosphate lah. So glucose is... Okay, you need to trap glucose inside the cytoplasm also. The first thing, trap the glucose. But in order for you to trap the glucose without letting the glucose being diffused back, you need to change the glucose into something else. That is why they say glucose have to be converted into glucose 6-phosphate in order to prevent that from being diffused back. If it's diffused back, then you don't have any glucose trapped inside cytoplasm. So will the glycolysis happen? No. Okay, then what happened? So ATP will donate inorganic phosphate to become ADP. Okay, so energy is released lah kan, I think it's released. So the first ATP is being used. This one have to take note, because at the end of step 5, you'll be having only 2 ATP being used. Okay, so enzyme involved inside this whole reaction is called hexokinase. This one have to remember. No shortcut also. And then what happened after this one is being kicked out from the ATP, the PI will bind to the glucose to form glucose 6-phosphate, which will look like this. Actually, it's just the same. It's just that they take away the hydrogen. They don't like the hydrogen, they put P instead. It's like, okay, oxygen, let's be friend with P instead of hydrogen. That's what happened. Okay, settle. This one have to remember. I think if you pro already, you just write like this lah inside the exam. If masuk the SCQ, for sure you got mark already. Instead of writing this one is a lot. But this one I do to make sure that you understand. And step 2 is isomerization. Isomer meaning that it's the same chemical punya tu, tapi the structure is different. Both got 6 carbon still, cuma different placement, something like that. Okay, so glucose 6-phosphate rearranged into fructose 6-phosphate and is catalyzed by enzyme phosphohexose isomerase. How to remember? See ya, nampak? Hexokinase. Kejap. Oh, this one? No. Kejap. Isomerase, isomerization. Okay? Nama dia actually very dekat-dekat one, which is exactly what happened here lah. There's not much yang happen. It's just they change the structure, but still C6 got 6 carbon. And then we go to step 3, is another kind of phosphorylation. So the second ATP is used up here. So the ATP will change into ADP with PI. So the PI will bond into the first carbon of fructose 6-phosphate. So right now, kan dekat sini, we have 1 phosphate already. So when I tambah another PI, how many phosphate you get? You get 2 phosphate in total. So that is why the name changed from fructose 6-phosphate to fructose 1,6-biphosphate. And this one is catalyzed by fructokinase 1. Settle. Okay, so far finish this one, we finish this one, we finish this one. And we go to step 4. Step 4 is cleavage. Cleavage means separate. Okay, so what happened in separation? So the fructose 1,6-biphosphate will split into 2 molecules. Different molecules are glyceraldehyde 3-phosphate and also dehydroxyacetone phosphate. This process is being catalyzed by an enzyme called aldolase. Okay, this one I need you to understand that this one is actually isomer of this one. It's the same punya how to say, they are the same chemical punya substance inside, tapi structure dia is different. Okay, we go to this one, step 5, which is the last energy investment, and we end it with isomerization again, because we actually don't want this one to remain this one. We need to change this back to glyceraldehyde 3-phosphate. Okay, so dehydroxyacetone phosphate is the isomer for glyceraldehyde 3-phosphate. So dehydroxyacetone phosphate will eventually go back to being glyceraldehyde 3-phosphate. Okay, so now from this one will change to glyceraldehyde 3-phosphate. So right now, in total, how many glyceraldehyde 3-phosphate you have? You have 2 molecules in total. Settle. Okay, this one is phase 1. We go to phase 2, which is energy payoff phase 2. It's phase 2 from step 6 to step 10. And the total ATP produced at the end of the day will be 4 in total, if we exclude the one that we have to deduct when we use inside the investment. Oxidation and phosphorylation will happen 2 times because there is 2 molecules of glyceraldehyde 3-phosphate. Okay, so this happens 2 times. What happened? This one will donate hydrogen, so they release this hydrogen. Okay, and then after that, this whole process is catalyzed by glyceraldehyde 3-phosphate dehydrogenase. Dehydrogenase punya ni is the one that helps to release the hydrogen ion. Okay, so in cytoplasm, the inorganic phosphate will be available and freely moving, so it will be attached to glyceraldehyde 3-phosphate and become 1,3-biphosphate glyceraldehyde. Why? Because this one got phosphate already. You put another phosphate inside, got biphosphate lah. So pergi dekat, they attached to C1. That's why you got 1,3-biphosphate. Blah blah blah. Okay. Then we go, this one is the equation kalau you nak see. I like this equation better lah than the explanation. Explanation is too lengthy. I got no time to read all that. And then we go back here. Okay, when they release oxygen, where does it go? It doesn't magically disappear. It goes here. So the hydrogen ion will be captured by coenzyme. Kan coenzyme NAD plus and FAD is the one yang the one that carries hydrogen ion and also accept electron, right? So when the electron is released, will be accepted to form NADH. This one times 2. Sebab apa? This whole process happen 2 times. Same like this one. Same like the rest. Times 2 also. Okay, step 6 gone. Go to step 7. Substrate level phosphorylation. Like I said. Okay, I don't want to repeat this one. Okay, we start with this one. But I upload already what? Okay, never mind. 1,3-biphosphoglyceraldehyde. 1,3-biphosphate glycerate. Blah 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 lah, doesn't matter. But this one releases one of the PI. Okay, this one got 2 phosphate kan, so I release here. It can also release here, doesn't matter actually, whichever lah, but release here. And then this one, when it's released, it will be taken up by the ADP to form ATP. This one also happened 2 times. This one happened 2 times. This one also happened 2 times. So the reaction is catalyzed by phosphoglycerate kinase. This one also settle. We go to this one. So right now, you buang 1 kan, you tinggal 3. That's why this happened dekat 3. Okay. So, betul lah. 1, 2, 3. 1, 2, 3. Salah. We release here, that's why got 3 still. Okay. Then 3-phosphoglycerate will undergo isomerization, producing 2 molecules of 2-phosphoglycerate, and then this process will be catalyzed by phosphoglycerate mutase, okay, to form 2-phosphoglycerate. This one 2 as in like this one is located in the second carbon tau. Okay, but this whole thing has 2 molecules of it, so that's why it's 2. Don't mix it up. And then step 9 is dehydration. This one is where you can get the 2H2O. Okay, so in step 9, basically this one, the one that we get, will undergo dehydration, so water molecule is removed. How to get water molecule removed? Kalau in exam kan, you write like this, you lukis this one, and then you take the OH from here dengan H from here, you remove this one. This whole process will be catalyzed by endolase, and then this is what happened lah. Nampak tak? There's no OH left. This one also missing H. This whole process happens twice. That is why we have 2 molecules of water. Okay, this one we went from 2-phosphoglycerate to phosphoenolpyruvate. This one, the one that I talked about just now, the ATP formation. Okay, and then process is catalyzed by this one same. We're about to finish, guys. Substrate level phosphorylation. Pyruvate kinase, which is an enzyme, it will bind to phosphoenol pyruvate, and then the inorganic phosphate will be released because inside here still got phosphate. We don't want this. We don't want this whole thing. We want pyruvate only. Because this thing, if this does not happen, we cannot go through to the link reaction, which is the second step. Second step ke? Not second step lah. Second reaction lah. We call second reaction. Okay. So, what happened to the inorganic phosphate? It goes back to the ADP lah. ADP will take PI and then form ATP. So, this one you also we times 2. So, total how many total ATP produced? You have 4. Sebab this one you have 2 ATP here. Okay. And then another one you have in step 7 also you produce 2 ATP. Okay. Now, if the question say what is the net ATP after everything, only then you jawab jawapan A is 2 ATP remaining. Kalau dia tanya what is the total ATP in glycolysis, only then you see 4 ATP in total. Okay, don't mix up. So what is the stuff that you dapat from this glycolysis? You have 2 ATP, I have 2 H2O, 2 pyruvate, 2 NADH. Okay, this one you have to ignore sebab this one is considered as byproduct already, so you won't be using it. Okay, pyruvate, NADH, we'll be using it for the next reaction. ATP also, I think. You need to, okay, the reason why I give this, just in case you don't understand. Tapi, kan, if I were you, I think I will understand better with this kind of, apa ni? This kind of diagram. Because, see, this one, not too much word, and then you can imagine this diagram. So, yeah, use the slide lah. The slide is your friend actually. So, and they even color code the enzyme already. You just need to understand. You don't remember, you understand. If you understand the process, you don't have to memorize. So you can just take up other stuff for memorizing. So you don't waste too much brain punya capacity. This one, after you dah master everything, only then you do this. But I think even if you don't master, you just do this still lah. Try to do this, because this one is very important. I think if you can do this, then you will understand the whole thing. Oh, I have class at 1:30. Okay, so link reaction I'll do later. Maybe tonight I'll send. I'm not sure. I won't promise anything. Okay, that is all. Crab cycle also later. Bye bye.